Power to the truth. This is Margo. This is Tuesday, September 25th, 2018. And today we're going to do an Arctic sea ice update and kind of round off the season as we're ending our melt season, traditional melt season. And also going to be looking at the Antarctic now that the sun has come up down there, and look at things that are going on there. And I've got some articles to share today, and we will do our update on our greenhouse gases on cams. So sit back and just enjoy the update here. My last update was on September the 14th. So it's been a while. I had to take a little bit of a break and kind of recuperate. I was pushing myself too much, and I was pretty near physical collapse, and so I had to pull back. So I'm just going to have to pace myself a little bit better. And I apologize for canceling the campfire chats at the last minute, but the live shows really take it out of me. And I'll see if I'm able to do any live shows in the future. I really am exhausted after I do a live show, so I'm going to have to rethink that. But I will continue with the updates and with other shows as they come up, and we'll be putting them up on my YouTube channel. So I'd like to thank all of my listeners and everyone for being patient, and thank you for your kind comments and checking on me, because I know you got used to having me put something up every 2 or 3 days. So I'll do what I can, but this is my first year to be tracking all of this data and going through everything. And what we have up here is this is from Climate Reanalyzer. This is the sea ice and snow cover from today, Tuesday, September 25th. And here is the extent in this computer model. And we can see that it's still quite thin up there. And I'm going to zoom in on this a little bit so you can kind of get an idea before we go to the other websites to see what we're dealing with here. And it started refreezing somewhat, but it's still quite thin. And it started to refreeze up here in the Siberia Sea, and we still are really quite open here in the Bering Sea, and it's still way open over here on the right, and Greenland is still pretty much ice-free all the way around, although we're getting some ice coming back around the northern edges, and in these little tributaries around these islands, the ice is starting to come back. Now some of this is snow that you're seeing. It's been snowing up there because it's cold enough that the snow has begun, but they're still getting rain, and they're still too warm up there, and there's still a lot of mixing going on with the ocean from the Atlantic and from the Pacific coming in, and it's much warmer than the Arctic Ocean, and so we still have this mixing going on underneath. And so in spite of the temperatures falling now and the sun going down, and so we're headed into darkness in the Arctic. It's not quite there yet, but it's getting there very soon. In spite of all of that, we have this warmer water underneath and eating away at the edges of this sea ice And so it's like in a tug of war. It's in this battle trying to reform, but this warmer and saltier water is trying to eat away at it, and it's coming up underneath, and it's trying to freeze, and so I don't know how thick it's gonna be. I don't expect it to be very thick at all. And also what you're going to see from the Navy view is that it's still been thinning, even though it's been refreezing and the extent is coming back. It's still been thinning in these thicker areas. I'm going to show you that as well too. So we're not out of the woods, even though we did not have the blue ocean event this year. We're not out of the woods, and we still have big problems. And so don't put all your money on having that we're going to be okay if there's not a blue ocean event. No, we're not okay. And my message has been, and is still, time is short. We don't know how much time we have, but we've been given a little bit more time to do what we have to do to get ready to exit the planet. We're still in the midst of the sixth mass extinction, and there's still no fixing this problem, and Mother Earth is in huge trouble, and civilization is in huge trouble, and all the viable life on the planet is in huge trouble, and we're going away. We're going away, and it's just the way it is. So we have a little bit more time to get our spiritual houses in order. And so, we need to be focusing on that, not focusing on nitpicking and tearing people apart and being mean and hateful and all that stuff. So it just bothers me to see that go on. It just pains me. And, I just have to step back from it and isolate myself from the world when I see all that go on. So let's just take a little slideshow back and look at what's going on in the last few days since my last update, so that we can see that the sea ice is starting to come back a little bit with the colder temperatures now. Here it is from yesterday. Now, okay, so it's diminishing now as I'm going backwards, and you can definitely see the changes. And just in the last couple of days it started coming back a little bit. This area up here, this little area up here that's just very very lacy. I call it lacy because it's just not very well formed at all, and is just little chunks of sea ice. I really expected that to go away, but it never did completely. And so so this is from September the 10th, so we'll go forward in our slideshow now, and you can see now here's where it was really, on the 12th I'm like, this is gonna go, when I saw that. But it held its own, and you can see that parts of it did go away. We did have some storms up there and some rain and wind and different stuff, and I really thought that that area was just gonna peter out, but it hung in there, and now it's started to refreeze and come back a little bit, and here we are on today, the 25th. Now here's the Navy sea ice thickness from today, the 25th, and we can see that it's still quite thin. It's quite thin, and as the old sea ice that was 2.5 meters and more, it's just it's very, very little bit, just a little tiny bit right down here. Here, I'm going to blow this up. We have a little bit right down here on the northern edge of these Canadian islands, and we have a little bit of red here right above Greenland, and then this is the aqua colored, which is about 2.5 meters. The red is more like into the 4 meters, and then it's coming back just very thin here around the edges, and it's going to be coming down from the north and then around here in Baffin Bay, and it's coming back in these little tributaries here too. But the extent is still very diminished. This is the 80-degree north latitude circle around here, so it's still really diminished in from that. And then here in the Beaufort Sea, we had some days, we had quite a few days of just no cloud cover, and I'm going to show you that on Worldview as well. That was just totally open, and it was amazing to see just wide open space with no sea ice there and no clouds, and we were also seeing like this blue-green stuff off the coast of Alaska, which we think was algae. I wasn't able to see that before all this cloud cover lifted for a few days, and there's a bunch of brown stuff too, like sediment. So so there you have that. So here's the animated GIF from the Navy. It goes for 30 days, so it's 3 weeks before now, and then it's going a 7-day forecast. So to October the 2nd is what it's forecasting to here. So I'm going to stop this, and I'm going to okay, so here we are on. Now I want to go back, and I want to show you what's been happening with the sea ice in the last 3 weeks. Here it was on September the 3rd, and you can see we had quite a bit of area that had the aqua color, okay? And the aqua is like 2.5, between 2 and 2.5 meters thick. And so we had that, and then the blue is like 1 to 1.25 meters thick. So we had that, and you know, the dark blue-green 1.5. So we had all that going on here, but I'm gonna just click these forward, and I want you to watch in here in this area, and I want you to watch these colors shift and change, because you're gonna see this thick ice going away. You're going to see it get thinner and thinner. And see here on the 8th, this tributary opened up with almost no sea ice, and you see how much thinner that's gotten. Much less blue-green. And you can actually see it moving and melting, and like just going through these tributaries, opening up. Here it is on the 17th, and now this whole area that had blue-green is down into purple, which is like down in like under 1 meter. and there's white there, which means there was none. And remember, I was showing there were large areas where there was no sea ice around these edges. None. And this is that old sea ice. And this is why everybody, all the experts were all up in arms about the melt this year, because without that old sea ice, what we're heading into at the end of the melt season is very thin sea ice, and so we don't know how thick it'll be. It probably won't get very thick during the winter. We'll get an extent. The extent will come back, but I don't expect it to be very thick. And so come spring, when we start getting the warming again, yeah, we'll have some extent back, but it's going to be so thin that ice is going to melt so fast. We could have the blue ocean event very early in the season, and catastrophic weather. That will set us up for catastrophic circumstances to happen within a very short period of time. So by next summer, we could be in big trouble. And I think we're already in big trouble. So here it is, and this is as far as this goes on the forecast. And then they're forecasting that it's starting to come back a little bit thicker. But even at the end of their forecast period here on October the 2nd, there's no blue-green here. See, it's just barely a little bit of purple there, a little bit of blue-green here, and then it's purple all around these edges. So even during this last part of September, we're losing this thickness. Which means it's still melting. The melt hasn't stopped. That's what that means. Okay? So, now I'm going to leave that. And I've got Climate Reanalyzer pulled up here. We're just going to make the rounds here. And this is our 2-meter temperature around the world. This is average, maximum, and minimum. That's how cold it is. And we can see that it's definitely getting cooler up in the Arctic, which it should. But if you click on the 2-meter temperature anomaly, it's still much warmer than it should be. This is the air over the Arctic. It's still a lot warmer than it should be this time of the year. And so it's going to make that refreezing harder. If the air is too warmer than it should be and the water is too warm, you're in trouble. I mean, we're just not going to have that refreezing the way we should. And here's our precipitation and clouds up there. We can see that it's raining up here. Up here in the Kara Sea, over to the right of Novaya Zemlya, we got huge rain. And then this blue is snow. And when we go to NASA Worldview, I'm going to show you, you'll see the snow on the ice. And it's snowing over here. Then it looks like, and I know that England has had a big storm. It's just, and my God, when I was going to do my show, was like, oh my God, we'd had all those hurricanes, and I was just worn out from the emotionalness of everything, and I was just drained from the drama, just high drama with this stuff. I didn't know climate change could be so stressful, but my God, you got to take a break from it every now and then. Here's the jet stream, and we can see that it's Here it is up here, and that's where that rain and snow is coming in, and then it's coming down over here and around, making a loop. And here's our snow depth. We can see that it's already snowing, and we have a snow depth. This is in centimeters of about maybe 4 centimeters right at the North Pole and some different places. So it's getting there. It's getting there. It's snowing in Greenland too. Their snow depth is higher. And it's snowing up here in northern Canada, the Northern Territories, and it's starting snowing a little bit over here in Siberia and in Iceland. And then sea surface temperature, there's that, and the sea surface temperature anomaly. We can see that this sea surface temperature is still in the red all the way around here in the Arctic, and coming up around the edges of that sea ice, it's red and brown. And so that's another reason that our refreezing is gonna be less. We've got trouble. So I might come back to Climate Reanalyzer. I want to move on with the Arctic, and then we'll come back to Climate Reanalyzer if we have time. Okay, now we're going to look at the National Snow and Ice Data Center Arctic Sea Ice News and Analysis. Here is the extent for September 24th, and we'll make this bigger. Remember, extent means just how far out they had frozen areas of the water. And it doesn't mean thickness or concentration. This is the extent. And even with a very thin layer, it can still reflect the sunlight, and which is what we want. We want the sea ice to reflect the sunlight and to keep it cooler up there. But so it's still very, very far in from this brown line, which was the median edge from 1981 to 2010. It's still very, very far in, very reduced. Here's the concentration for yesterday, and this is according to this graph over here, this chart, and it's quite thin, as we can see, and it just backs up what we see on the Navy graph as well. And here is the sea ice extent, and we see that the extent it took a nosedive. It's really low. Now this dotted line was from 2012. That's when the extent was the lowest. And so we didn't hit that low, but it's still low. It's lower than all those other years up there. Okay? So we're not out of the woods. We're just not out of the woods. And now I'm going to show you the Antarctic sea ice extent. And they had, at first they thought they were doing okay, but they had a very low year. They had the lowest year on record for extent as well. And now they're heading into their spring and summer down there. The sun has just come up, and it won't go down for several months, and so all of this ice is going to be melting, and normally it all pretty much melts down there, and then it comes, and then has to come back during your winter time. So as we head into winter in the Arctic, we're heading into summer in the Antarctic. So the ice is different and everything is different in the Antarctic than in the Arctic because we have land in the Antarctic with glaciers and ice shelves on them in addition to sea ice, whereas in the Arctic we don't have land, we just have the sea ice. So it's pretty thin. It's not real concentrated, although when I did my research they said that during your winter time it only gets to be several meters thick. But I'm telling you, this is not several meters thick, and it's not very concentrated. I'm going to show you that on the Navy website too. So we're in big trouble in the Antarctic too. I'm going to show you that. Okay, I got to go back here and go through my charts. Now, here's this chart with Antarctic sea ice extent. This is the area of ocean with at least 15% sea ice. The blue line is this year, and see how, okay, and last year, 2017, was this thick line. Last year, 2017, was the lowest of sea ice extent, and this year we dropped below that, below the lowest in September, and now it's coming back up. So now here's the Navy website for the Arctic, and I already showed you the thickness and all that from the Navy. Here's the concentration from today, and we can see this area over here in this northwest area. It's still not as orange, but it's getting more concentrated throughout, and I'm thinking it's because the snow and everything is like filling in the cracks. So here's the sea surface temperature. We can see it's really warm on those edges. This is sea surface salinity, where it's mixing in, and it's really mixed in underneath the edges of that sea ice. And so with the salt water mixing in with the fresh water, it's going to be warmer. So now I'm going to show you, while we're here, we're going to look at the Antarctic. And we're going to be shifting our focus to the Antarctic as it gets dark up at the Arctic. And we're going to be following certain things going on in the Antarctic. And what we have here, this is the thickness, sea ice thickness from the Antarctic from today. And we can see, I don't see any red. I don't see anything that would show 4 meters of thickness, and they're at the end of their winter. Oh, here's a little bit of red down here. I almost have to get my magnifying glass out to see that right down here on this edge. So this is the East Antarctic. This is the West Antarctic. This is the peninsula, and your landmark is this peninsula with the tail, and here's the tail of South America, and these two tails point towards each other, and that's how you know, because sometimes you'll see this flipped around just depending on your perspective. And so there's a couple of areas we're going to be watching right off the bat. Is the Larsen ice shelves along here. We're going to be watching those this summer. We're going to their summer. And there's an area right down here that has a glacier. We're going to be watching that, and we're going to be watching the Ross ice shelf, and we can see that there's no ice right around the coast on some of these areas. And so I'm going to do some more research and find out if that's normal or not, and try and find out why is there no ice around the coast at the end of their winter time. What's the deal? If this is when this is the thickest and the most ice that they've got, what's going on? Do they normally have ice there? I don't know. We can look back, we can look back and see. Let's just see, like on September, like this time 2 years ago, September 25th, 2 years ago. Well, it looks like the extent was a lot better 2 years ago. See how much further out it went up here, but the thickness and it was, they had more blue, whereas we have more purple this year. But around the coast, it looks like they didn't have ice right up around the edges on those areas too. So that's just some things I'm going to be looking at there. So we're going to leave the Antarctic for right now. We're going to leave that website. Now we're going to hop over to NASA Worldview. I need a drink of water. This is the North Pole from today. I'm going to refresh and see if we have all of our data in yet. It looks like we do. And one thing that I noticed, and this was in my that report that I did with Robin, is that for whatever reason, as the data comes in, these pictures look like they get sliced and diced when they're put together. I don't know if they're from different satellites that come in at different times of the day, or for whatever reason it looks, these pictures get sliced and diced up, and so you'll have like a line here. If you follow my arrow, you see this line here, and you see it looks like a different picture, where this is the sea ice here, and it automatically cuts and then goes to clouds here, and it's a whole different picture. So I don't know why they can't match them up. They could match them up if they wanted to. That's just what I'm saying. I just think it's sloppy not to match them up. So I'm not going to spend a lot of time on that, but that's an observation. And my other observation was the black stripes that tend to show up more in the morning than in the evening after they get through slicing and dicing. But these black stripes that still show up, I'm not seeing them right now, because you have to have kind of a lighter background to really see them, and you have to zoom in. And I don't buy it that its camera shutter speed is wrong. I don't buy that explanation that someone was trying to give me. I have my own theories that I won't go into because I just want to stick to what I'm showing you here. So what we're seeing here today is we're seeing this blue-green off the coast of Alaska, which we're thinking this is algae, even though it's supposed to be cold up there, but the temperature of the water is 271.3 degrees Kelvin there. As I move my cursor over it, it's right around 271. So it's pretty close to freezing. So even with it pretty close to freezing, they still have algae growing in the ocean. And I'm thinking, I don't know why that is. Anyway, it's blue, green, and brown there. We have a lot of cloud cover today. Over here where this is cloud free in the Chukchi Sea, or no, this is the Bering Strait. It's 280.2 degrees Kelvin, so it's quite a bit above freezing. Freezing for fresh water is 273, I think. Freezing for salt water is 271 degrees Kelvin, or around there. So we have a lot of clouds. Let's zoom in these areas where it's kind of cloud free. And we'll look at the sea ice and the snow cover. And we can see it looks like cut and paste here with pinking shears. With that picture, you see that? That zigzag? You know, that's just a very sloppy cut and paste in my book. But we do see the cracks in the sea ice. It's still cracked. We still see this is the edge of the sea ice. Okay, this is clouds. That little swirly stuff it looks like is clouds. And we see that the sea ice here on this edge, it's just chunks. These are ice cubes. And it's got to refreeze and all come back together somehow. So that's where we're at there. And we can see this big hole getting bigger. This is because the sun is setting, and so we have less of a view of the Arctic here. Let's stay up here on this northern part while I'm at it. Here's the edge of the sea ice up here on this northern part. We can see it's just, you know, a polar bear couldn't go fishing on those ice chunks. No, there's just no way. And then we've got the pinking shears putting the picture together here. And here's, we're looking through a little bit of cloud cover. It's still quite thin. And so the navy model of the purple and the little wispy stuff through the purple is, I think, is quite accurate. And then we have so much cloud cover, it's just hard to really see through anything here. Here we've got a little bit of break in the clouds down here. So we can see it's starting to, it's getting a blue tint now. I don't know what that means. It could be the angle of the sun is making it blue. I don't know. There's the edge of the sea ice through the clouds. Here's northern part of Greenland. This is cloud covered. No, we've got, okay, so a lot of this is not cloud covered. So we can actually see the ice as it's coming, refreezing a little bit here, but we can still see that it's probably a lot of snow. Let me add the snow layer and we'll be able to see snow cover. We can add this layer and we can see what's snow covered and what's not. Okay, it's actually not showing, it's only showing the snow on the land, not really over on the ice that much. I guess they're thinking that they would only want to see snow on the land. So here's our snow cover in Greenland. And this is, I'm not sure how to read this. It's an index 81. So if I put my cursor here, that's a 64. That's kind of that orangey. And then the pinky color, that's like a 74. So the more pink it gets, the thicker it is. The more snow you got. That's a 69 down there. So I'm going to turn that layer off. So now we're going to turn on our cloud. Okay, see where the clouds are. So as I was saying, it's starting to either freeze back or the ice is getting pushed over towards the coast, or both. So until we go into total darkness, we can keep looking up here and watching the freezing patterns, and this will be interesting to watch as well and to document. And we need to be documenting these things, and this is why I'm gonna keep doing these reports year round until we're not here or not able to do it, because you know the internet may not be here forever, as we know. Because we need to be looking at this, and apparently the climate scientists aren't reporting on this, and so it takes someone who's not a climate scientist to report. Because the climate scientists are afraid of losing their jobs or losing their lives. And me, I'm not a climate scientist, so, you know, I'll just do the best I can and bring these images to you, and you can make up your own mind. And you can see even here, this is the Beaufort Sea. This is quite warm over here. It's 273. That's freezing. And so it's got to be below freezing for the ice to form. That's a cloud there. So I'm going to take you back a few days and show you how this Beaufort Sea was just cloud free for days on end, and it was so interesting. Okay, here's where it started. My last report was on the 14th. I'm going to zoom in, and it was, look at this area up here that was cloud free. So you can really see the extent, or the edges were really right around here. I had a little bit coming out around there, and then down here, and this area was totally open. So I'm going to zoom in here, and we can see a cut and paste job here. So this was the 14th. Here's the 15th. Here's the 16th. '17th. 18th. Here's it opened up again. Look at this big hole. Look at how round that is. For whatever reason, that big round hole opened up, and that was just fascinating to me to see this all open up like this. And I guess yeah, these wispy things are clouds. Isn't that interesting? Those are clouds there. And I guess this, I was thinking that was ice. I'm not sure if that's ice or not. It's showing up as clouds. So, what can I say? And it was quite warm. It was 276.1 Kelvin right there in that little yellow part. So it was very warm. This whole round area was very warm. So for days on end, this area was just really getting a lot of sunlight in. 272. So this whole area was baking. So it absorbed a lot of heat right at the end of the melt season. And see here, there's still quite a large open area down here on the 21st. So they absorbed a lot of heat during those days. And now it's clouded over. So here we are on the 25th. So there's that. Now I want to hop down to the Antarctic while I'm here. And what we can see is the hole in the center is getting much smaller because the sun is coming up, and within a few days that hole will go away, and it will be daylight year-round down there. And so we'll be able to get a good view of everything. So here is the Antarctic as of today, September 25th. I'm going to turn off this, I'm going to get rid of that snow layer. Okay, this is showing us where it's cloud free, so we can zoom in. But we can see the edge, the ice edge is kind of around kind of around there like that. And if we zoom in over here on the Larsen ice shelves, we can see that on this tippy point it's pretty much ice free. See, there's a little bit of ice down here. This was Larsen A. This is Larsen B, what's left of it. This is Larsen C. This line here it delineates where that chunk of the Larsen C ice shelf broke off in 2017. And this is the iceberg that broke off. Right here we've got a really good view of it today. And it has rotated and it's broken off, it's on the move, and it's just got this sea ice just holding it back, and that sea ice is not very thick, and it's all going to be melting, and it's on the move. And this is that trillion-ton A68 iceberg. So we're going to be watching that. Now I want to show you it. We had a better picture of this yesterday. There was no cloud cover yesterday, and you can really see that iceberg. It's humongous, and it's rotated even more around. Last time when I showed this, it was closer to the Larsen Sea, but it's moving out, separating, and is more rotated in this northwest position. Now these are clouds here, but this is the ice that's holding it and keeping it from going out into open waters. So we're going to be watching that as the summer rocks along. There's another area over here that we're going to be watching. It's right down here. Let me go back to today, get a better view. It's right down here, and I have an article that I want to share about this area. There's a glacier that's in this area on the land, but now they're thinking that it's more floating on the sea, and it's melting, and it's coming out. And we're in big trouble. When this melts, there will be a lot of sea level rise, and it's melting. And so we can watch this as it starts to come out as well. And you can see here that the ice is already broken up. It's the beginning of the melt season. So we're looking through clouds here, and we're looking through a thin layer of clouds, and there's no ice here. No ice along, well, a little bit of shelf here along the coastline. But look at this huge area that's open, and this is where that glacier is coming out. So as it melts, we're going to be watching that this year. So let's hop over to our articles now. I'm going to start with this article about the Antarctic. This is actually from March 20th, 2018. I thought this was more recent. Anyway, that's okay. We can be watching it. More of a giant France-sized glacier in Antarctica is floating on the ocean than previously thought, scientists said Tuesday, raising fears it could melt faster as the climate warms and have a dramatic impact on rising sea levels. And so here's our picture, and this is the glacier, and it's called the Totten Glacier, and it's quite large. And I've got I'm going to pull up an enlarged picture of that for you. I'm going to blow it up so we can really get a good look. Down here, okay, here's the Ross Ice Shelf, and it's over here on this eastern side, and it's coming out right in that little area, that's that nick. There's a little nick in there, and that's where it's coming out. And so when we look at NASA Worldview, it's right down here in that little nick. And so, you know, when we have cloud-free days, we'll be able to see this glacier. Uh-oh. So there's a lot of clouds down there right now, so we can't actually see the glacier, but we can see, we'll be able to watch what's going on as it's coming out. So let's go back to our articles here. The Totten Glacier is one of the fastest flowing and largest glaciers in Antarctica, with scientists keen to keep a close eye on how it melts given the enormous amount of water it could potentially unleash. Using artificially created seismic waves that help scientists see through the ice, researchers have discovered that more of the Totten Glacier floats on the ocean than initially thought. In some locations we thought were grounded, we detected the ocean below, indicating that the glacier is in fact floating, said Paul Winberry from Central Washington University, who spent the summer in Antarctica studying the Totten. The findings are important because recent studies have shown the Totten Glacier's underbelly is already being eroded by warm, salty seawater flowing hundreds of kilometers inland after passing through underwater gateways. Does that sound familiar? Salty seawater coming in underneath. As it does, the portion of the glacier resting on water rather than rock increases, accelerating the pace of disintegration. Winberry said more of the glacier floating on a warm ocean could help explain recent periods of accelerated melting. It also means the Totten might be more sensitive to climate variations in the future. Glaciers are huge bodies of dense ice that slowly move down valleys, mountains, and slopes under their own weight over many centuries, sculpting the earth below as they go. They hold the vast majority of Earth's fresh water and are the main contributor to rising sea levels when they melt. According to NASA monitoring, between 2002 and 2016, Antarctica lost 125 gigatons of ice per year, causing sea levels worldwide to rise by 0.35 millimeters annually. From the air, the contours of Totten Glacier are invisible because the entire Antarctic continent is covered by a seamless, kilometers-thick blanket of snow and ice. Well, that's going to be melting. That's why scientists are so determined to understand what's happening underneath the glacier hidden from view. Team leader Ben Galton-Finzi from the Australian Antarctic Division said the Totten Glacier contains enough ice to raise global sea levels by about 3 meters or 9.8 feet if it all melted. So there you go. So they put their instruments down there and they're collecting data. So there's that article. And while we're in the South Pole, I have another article to share. This one just came out yesterday from phys.org. Study finds first evidence of climate change impacts on East Antarctic vegetation. A trademark 13-year study published in Nature Climate Change has provided the first evidence that climate change is affecting terrestrial ecosystems in East Antarctica. While West Antarctica and the Antarctic Peninsula are among the most rapidly warming places on the planet, East Antarctica has not warmed in the same way and appeared to have so far escaped the strongest impacts of climate change. The study, by researchers from the University of Wollongong, or UOW, the Australian Antarctic Division, and the Australian Nuclear Science and Technology Organization, found that vegetation in East Antarctica is changing rapidly in its response to a drying climate. East Antarctica, the researchers argue, has become colder, windier, and drier due to the combined effects of climate change and ozone depletion. You got that? Climate change and ozone depletion. Windier, colder, and drier. Starting in 2000, the researchers monitored old-growth moss beds near Australia's Casey Station. The lush green moss bed at Casey, known as the Daintree of the Antarctic, are the largest plant ecosystem in East Antarctica. And it goes on and on. And I thought they had a picture of the moss. There was another article that showed the moss, but apparently it's the only thing that grows down there, and now it's not growing because it's too dry. So, of the 18 mosses they sampled, most showed evidence of drying, and 40% showed evidence of significant drying. Only 3 didn't show drying, etc., etc. And so what they found was that the winds have shifted because the ozone hole and it's the UV radiation. It says another message that from this is that we don't necessarily anticipate the consequences of what we do. We knew ozone depletion would increase UV radiation, but it was decades before we knew it affected the climate. So there's increased UV radiation down there as well. So, it's just screwing everything up. Those shifting winds are affecting southern Africa and South America and Australia because they are pulling all the weather bands to the south. Some areas are getting wetter, and big areas that were wetter have gotten much drier. It's affecting how trees grow in New Zealand. It's affecting the southern tip of Chile, where trees are growing less well, forests are contracting, and there's less water for hydroelectric power plants. So there's that. So we're already at an hour and 4 minutes. I'm going to show you 2 more articles and then we're going to wrap it up. This is, now we're going to hop up to the Arctic. I'm going to take that down. This is from Anchorage Daily News from 1 day ago. The hissing, bubbling Alaska lake is frightening scientists. Methane gas is being released from this lake. This is the Essia Lake. You can see those ripples? That's methane bubbling up to the surface. Above the Arctic Circle, Alaska, Katie Walter Anthony, she goes by Walter, has studied some 300 lakes across the tundras of the Arctic, but sitting on the mucky shore of her latest discovery, the Arctic expert said she's never seen a lake like this one. Set against the austere peaks of the western Brooks Range, the lake, about 20 football fields in size, looked like it was boiling. Its waters hissed, bubbled, and popped as a powerful greenhouse gas escaped from the lake bed. Some bubbles grew as big as grapefruits, visibly lifting the water surface several inches and carrying up bits of mud from below. This was methane. As the permafrost thaws across the fast-warming Arctic, it releases carbon dioxide, the top planet-warming greenhouse gas from the soil, into the air. Sometimes that thaw spurs the growth of lakes in the soft sunken ground, and these deep thawing bodies of water tend to unleash the harder-hitting methane gas. So we know all about that. Anyway, this is all about that. So I'm going to leave the link below. You can read this article. She's actually catching the methane and is studying it. Here's how, look at this methane capturing device. It looks like a big kite capturing the methane. It's a measuring chamber. So, yeah, it's kind of freaky, that's to say the least. Here's this one. For methane researcher, golf course bubbles are a first. This article is all about a golf course in Alaska that it's got methane coming up out of these pools of water. This is Katie Walter Anthony again and her assistant. So this was from the lake, and so this is from a golf course. But so Katie Walter Anthony is on this as well. So for golfers at the North Star Golf Club in Fairbanks, there's an extra perk. If you come at the right time of year, you can find methane bubbles on the course. It's been happening for the past 2 decades, according to Roger Evans. So for the last 20 years, methane has been bubbling up in this golf course. People regularly poke them with teas and light them on fire. So that's their entertainment at that golf course. Anyway, you can read this article if you want. Here's a video. Watch this. This guy is going to be like, you hear that? That's methane under there. So That's methane under there. So you're going to have more and more of this kind of stuff. Now, one more article to share with you. This one is from Live Science from September the 18th. Melting Arctic permafrost releases acid that dissolves rocks. Now this one flipped me out. Runoff from melting permafrost in Alaska flows toward the sea. As temperatures rise in the Arctic, permafrost, permanently frozen ground, is defrosting at an alarming rate, but the permafrost isn't the only thing in the Arctic that's melting. Exposed rock that was once covered in ice is dissolving, eaten away by acid, and the effects of this acid bath could have far-reaching impacts on global climate, according to a new study. Icy permafrost is rich in minerals, which are released when the ice melts. The minerals then become vulnerable to chemical weathering or the breakdown of rock through chemical reactions, scientists recently reported. They investigated areas once covered by permafrost in the western Canadian Arctic, finding evidence of weathering caused by sulfuric acid produced by sulfide minerals that were released when the permafrost melted. So what they're saying is the permafrost is also releasing sulfuric acid and sulfur minerals. So we didn't know this either. So the permafrost is also going to erode everything that it comes into contact with. So I'm not going to read this whole thing. So, we're in big trouble. It doesn't matter that we didn't have the Blue Ocean event this year. I'm going to read this part. Thermokarst creates land formations such as lakes, pits, and sinkholes, and it was previously unknown how this process could affect weathering of exposed minerals and how that might then impact CO2 release, according to the study. These processes may influence the permafrost carbon climate feedback, but have received little attention. Yeah, so it's going to release, it's a feedback loop. It's just a new feedback loop. So there's that. Now, for what you've all been waiting for, my update would not be complete without a report on cams. I know this is long, but I have to do my catch-up. I'm going to start with sulfur dioxide. I already have the movie drawn up and pulled up. This is the Pacific view. There have been a lot of earthquakes and volcanic activity, especially on the Ring of Fire in the last couple of weeks. And so this is the Pacific view with sulfur dioxide at total column level from cams. Our base time is from last Friday going through today. So what you're going to see is, I already had this movie loaded up for you. This red, like all these volcanoes going off around this ring of fire and giving off this sulfur dioxide, the red and the gold, and then as it disperses it goes into the green and the cream colored. This is the Vanuatu area. This is this little area off of Papua New Guinea. There's a volcano there going off. Also, Indonesia has volcanic and earthquake activity going off. Hawaii's still erupting. Popocatépetl is erupting. Guatemala, and then down here in Chile, and then up here in Alaska. And then there was some stuff going off in the Galapagos that I didn't even really get. New Zealand, we've got stuff going on down there. We've got stuff going on over here in Australia. And then all of this China area is like gold colored. This is from the pollution, the sulfur dioxide from the pollution over there. And so we can see that the atmosphere is really becoming more and more filled with sulfur dioxide. And with this, it eats away at the ozone layer. It just eats it away and depletes it. And with the ozone layer depleting, we get more UV rays and more cosmic rays coming through. And then everything also just keeps heating up. And then we've got the methane, and then we've got the carbon dioxide, and you know, it's a whole combo plate. So I wanted to start with that. And now I'm going to hop over to ozone. And the first thing we're going to look at is the hole, the ozone hole over the South Pole. Now, this is when it's at its thinnest, because they're at the end of their winter, and that's when it's the coldest. And so we're going to go from today, and we're going to run the forecast. And so we're looking down on the Antarctic. And as this loads up, I'll go over the chart with what these levels mean and these colors mean. Okay. As that's loading, this okay, the yellow is 300 Dobson units. And then you start getting into the greens, and it starts going down to 280, 260, 240. This aqua color is 220 Dobson units. This kind of blue-purple color is 200. The blue is 175. The kind of the ocean blue is 150. And then the dark blue is 125. And then the black is 100. So this is the worst I've seen it. And from what Cam says and everywhere that I've read, this is when the ozone hole is the largest and the thinnest over the Antarctic, is at the end of their winter, because ozone, this is the good ozone, and this is a total column, and the good ozone is formed as a result of sunlight interacting with oxygen. And so with them being without sunlight for all these months, and it's gotten so cold, then the sunlight can't interact and make the ozone. You need heat interacting with the sunlight, warmth. And so now that the sun is coming up, we should expect this to start going back to more normal. But right now we're seeing the hole is totally engulfing the whole Antarctic region down here. And they're showing this black demarcation line between the 220, which is the aqua, and then the below that, which is super thin, and then the 125 is, it just looks like an amoeba just kind of morphing down there, and the cells dividing and going here and there. And it's huge. It's reaching all the way up to the tip of South America. It's huge. So let's hope it starts retreating and going back to normal. We'll be watching this too. And so the glacier that we were talking about that is over here, is right over here, right underneath that part where it's been thinning, and so there's no protection from the UV rays either as the sun's coming up, and so that means it's going to heat up faster and melt faster as well. So there's that. Now I want to show you, while we're on ozone, I want to show you the global view of ozone. Now this is quite disturbing to me because with it so thin at the South Pole, it's thinning. The green is thin even. The green Dobson units, this is how they measure ozone. And if you haven't seen my ozone videos, you need to go back and look at those. I did I think 3 instructional videos on ozone. But this equates to like 300 Dobson units is 3 millimeters of ozone up through the layers. So you can do the math. It's very thin, and that's what's protecting us from the ultraviolet radiation. So we can see that it's thinning all around the center of the earth. We can see that it's back to about 240 over here. In the South Pacific, it's about the 240. It's also getting thin over here in China. It's also thinning a lot up here in these Norwegian, well, no, that's not the Norwegian countries. This is Europe and Germany and those areas, and also Alaska. We're seeing it thinning. And it's thinning up in the Arctic, and we would expect it thinning in the Arctic with them heading into winter. The ozone hole kind of moves up to the Arctic instead of the Antarctic as it moves into the winter for the Arctic. So, but we should not see this thinning in the rest of the globe. We should not see the green that's that's very thin, and that's in almost all the northern hemisphere. So there you have that. We're losing the ozone layer. Next, I want to show you, let's look at surface ozone while we're here, and we'll be able to see like the pollution and the fires and things like that. It should have calmed down quite a bit by now. I'm going to go back to last Friday. I haven't been checking surface ozone recently. And this is actually measured in parts per million, but I don't think, know if they, nope, they'd say DU down here, but it's really parts per million. That's got to load up. So I can't wait so long between updates because they get to be too long when I do finally do them. Because I have to go through, and so much happens. So much has happened. But I couldn't do it. I had to take a break. I just absolutely had to take a break. So we're seeing the surface level ozone it's gone down quite a bit. Because with the cooler temperatures, there's not going to be as much surface level ozone forming with the temperatures going down. But we still have issues over, look over here in China. It's still red over there, and over here in the Persian Gulf. And the green, you know, over the oceans, the green. It looks like we're still getting a little bit of red coming up in California. There's still some wildfires burning. So, there's that. Now let's look at methane. I know everyone's dying to see methane because we haven't looked at it. Here's total column. That's the measurement all the way up through the atmosphere. Let's look at surface level. That's the one I like to watch. We're going to start with global since that's where we're at. And our data goes back to Friday. Let's just start with, well, let's go back to Friday. Let's load this movie up. For the globe for Friday, we'll see. That looks awful. Look up here. Look at this black coming up. There's Novaya Zemlya. This is the Kara Sea. And it's just, it looks like it's less over Norway and Sweden and Finland, those areas. But Siberia, Russia, that's still black. All across Europe, and you know, here's parts of Russia that are black. Is this loading? That's not loading. I've got to redo that. Now it's loading up. We've got all across India and China and Asia. Oh, and I found out where, you remember that article that I shared about that ship that was going to carry all those containers through the Arctic? I found the route for that. That was from Russia. And it was coming from over here, just north of China, and then it was going to come up here through the Bering Strait and along this coast, and then come around, and end up in Germany. And I don't know if it's there yet. We haven't heard anything. So that was the route. Now look at all this green coming up from the Antarctic. So there's methane coming up there too. Even though, because this is surface level, it's like 18, I would say that's 1840 or 1820. This is parts per billion down here in the Antarctic. So it's, you know, there you go. And we can look at up here. It's coming out all the way over the Arctic. Look how it just spreads out. It's all red over the Arctic. That's another reason that it's still melting up there. We've got methane coming up from the surface. Look at Iceland. This is Iceland here. We can see it popping up. Now watch. When it starts over, you're going to see methane popping up out of Iceland. Watch here. See? Look at that. Huge burst right there out of Iceland. Look at Canada. And look at northeast United States. It's still coming up all the way through Mexico and Central America and northern South America and Africa. And parts of Africa are still really super hot. And so here's methane. Here it is. This is all that red area in Alaska. So there you go. Fairbanks is down here. So that golf course that's got methane spewing up for the last 20 years is down here. So we're just now able to look at it ourselves without the climate scientists hiding it from us. Now we're going to go up to the Arctic and we're going to get a close-up and personal look at methane for this week. This is what we missed this week. Yeah, it's just as well. I would have been having nightmares if I'd been showing this to you all. It's freaking unbelievable. Seriously. Oh, look up here. Look up here. This is that East Siberia ice shelf. It's coming up. See? Right there. Look at that black over there. Oh, no, it's not. I'm confused. I hadn't looked at this in so long. That's Siberia. But we do have it coming up out of the Chukchi Sea, out of the East Siberia Sea here. It's coming up. Look, right out of the middle. Here's Alaska. Look up here. Okay, it's got to load up and then it'll run. Okay, here's Novaya Zemlya. We've got this big black area coming up here and just waves. Look at the black just coming up in waves out of Russia. Look at that. Oh my gosh. And it's cooler. It's getting cooler over there. And it's still popping up like that. That's like in the middle of summer when it was coming up. That's crazy. So these readings are, the bright red is about 2,000 parts per billion. The darker red is 2020. The brick red is 2040, and then the black is 75,600. So we can see it's still coming up in Canada and in the northern United States and, you know, different areas as hot spots usually. And just really coming up here out of Russia and Siberia, this whole northern area. And even the yellow is high. The orangey and yellow, that's like 1920 to 1940. The gold is 1960. Here's the gold there. Oh, look at Iceland while we're here. Let's look at that. as it runs through. There it goes. See? Look at that. It's like that one day, Sunday, it's just like the whole little island just went poof. It all just like released a whole bunch of methane. Watch it again. This is interesting. Here it comes. Here it comes. Here's Sunday coming up. Look. See? Wow. Wonder what happened. Okay, and now to close this out, we can look at carbon dioxide. And let's just go to the global view for this. And total column. And we will base time. Let's look at it for today and let it run the forecast. Here it is, or from yesterday. This is a day behind. And it'll run the forecast. So we're going to let this load up. And here's our chart down here. This is parts per million total column. And these cream colored are in the 400s. Like here's 410. 410 is getting more towards the brown. The really like the cream colored, like down here, that's about 407, 408. Then the browns are getting into like 414 and higher. The dark brown is 418. And then this black, the highest on the chart is 1,000 parts per million. I wonder if they expect it to get that high. So the Arctic is less in carbon dioxide. The mid-latitudes are higher in carbon dioxide. And then the South Pole is higher in carbon dioxide than the North Pole. For whatever reason. So there you have it. I think I'll probably divide this into 2 parts because it was so long. So my name's Margo. My website is margoshealingcorner.com. I do holistic life coaching and I do channeled star family readings for people. Time is short. It's time to get your spiritual houses in order. I love everyone. Until next time, go in peace. God bless and goodbye.